Hello, a very warm welcome to you. Once again, thank you for joining. This is Dr. Zulfikar Kassam. Today we will be talking about the application layer. So this is lecture 17, section 2, the last lecture in section 2. We'll go to the knowledge check in the following lecture, and after that we'll start section 3. So the application layer is the highest layer in the OSI model. It's the seventh layer of the OSI model and acts as the interface between the end user software and the underlying network services. It enables applications such as web browsers, email clients, and file transfer programs to exchange information reliably. So you may have heard of protocols like HTTP, HTTPS for web access, SMTP, IMAP POP3 for email services, and FTP for file transfers. These protocols basically define the rules for communication at this layer. It is responsible for formatting, managing, and presenting data in a standardized way to ensure that information sent across the network can be understood and used meaningfully by end users. So now let's talk about each and every protocol series and what that entails. All right, the application layer protocols, the first one is the web protocols. Basically enables us to use it for web browsing and content delivery. So there's HTTP and HTTPS over here, right? So basically what we want to emphasize over here is to make sure we don't use HTTP, right? HTTP is very insecure. Basically, all the information that is passed on to the network is going to be sent in clear text in this case. So any attacker can actually eavesdrop and look into the network and determine exactly what type of data is being exchanged between you and the server. So definitely don't want to use HTTP. So make sure this port is not being used, TCP/80. Right? And then HTTPS is what we would like to use, which is port 443. However, remember we did do a test last time and understand that right now with HTTPS does support SSL as well as TLS. However, you want to make sure you don't use SSL. SSL version 2 and version 3, which are both insecure, and even TLS version 1 and 1.1 are considered insecure. Um, you'd rather want to use TLS 1.2 and 1.3. So we had more information in the previous lecture. Please feel free to look at that to get more information about TLS. Okay, that uses port 443. Second set of protocols is file transfer protocols. They are basically used to move files between systems. Now they range a lot from what they do, right? This FTP, file transfer protocol, uses port 20 and 21. We'll talk a lot more about FTP in future lectures, how the ports are being utilized in that case. Basically, it's port 20 and 21. You once again don't want to use FTP directly because it is also not secure. You may want to use secure forms of FTP. So which is the FTP secure, which is FTPS, right? Which uses SSL and TLS, right? Port 990 and 989. Alternatively, you may consider using SFTP, which is using SSH with FTP. So instead of SSL TLS here, it uses SSH, which is very secure in combination with FTP. And that's on port 22, just like SSH is. That is secure FTP. Or you can use a trivial file transfer protocol. This protocol is used for very, very small files. Okay, it's not used for large files. FTP is the right one, and as I mentioned before, you want to use the secure forms of FTP, so FTPS and SFTP. Those are for large file transfers. If there's a very small file transfer involved, people tend to use the TFTP, which is a simpler form of FTP, uses UDP port 69. Then there is the SMB and SIFs, right? The SMB is server messaging blocks, and SIFs is the common internet file system using port 445. SMB is what Windows uses for file sharing. Unfortunately, the problem with port 445 is that if you keep it open, which is necessary for file servers, so you cannot close that port for file servers or print servers, they use port 445. But if you have a web server, for example, you may want to close this port. And any server that doesn't use this port for file sharing, then you may want to consider closing this port, because this is the port that the worms use for traversing the network. Once you get one infected machine on a network, they will use port 445 to trigger or transport that worm to all the machines in the company, right? So be very careful with TCP 445. If you ever have an issue of worms traversing the network, check 445, right? And sometimes you cannot close it completely, but you may want to block it temporarily if the viruses are going viral within your network, right? So keep an eye on port 445. Then there's the network file system, mostly used by Unix and Linux server, a very secure file system if you're using VMware, which is a virtualization platform. NFS is basically um, a very good platform to use for storage, right? NFS storage, very, very robust and highly scalable. Then we come to email protocols for sending, receiving, and managing email. This is SMTP, Simple Mail Transfer Protocol. It uses port 25 for transferring email or sending email. And if you want to use a secure form, which is much better, of course, it's 587 for secure. And there's the IMAP, which is the Internet Message Access Protocol. Uses port 143, but the secure form uses 993. And there's POP3. Okay, we'll talk about the details of email protocols in a later lecture. So, which is the Post Office Protocol version 3 and uses TCP port 110, and the secure form uses 995. The reason I'm kind of um, emphasizing on the ports for each and every of these application layer protocols is that this is the, of course, the layer 4 information, but these are the ports that you need to understand and be aware of which ones are required and which ones are not needed on any server, and close down the ports you don't need, right? And of course, open up the ports you need, right? Then there's the remote access protocols used to allow control or logging to remote systems. This is SSH, Secure Shell, which uses TCP 22. So ideally, you want to use SSH if you want to log into, let's say, Cisco switch, right? Or you're going to log onto a Linux machine. Try to avoid telnet, uses port 23. You may want to consider closing this down. I did mention in one of my lectures that you may want to keep telnet open for Cisco switches just as a backdoor, meaning to say you obviously want to use SSH. Telnet would be the last resort for whatever reason you cannot get into the switch, forgot the SSH password, or whatever. Then telnet could be used as a backdoor, but try to limit the amount of telnet, because this is once again sending information in clear text. Okay. Then RDP, if you have a Windows machine that you need to RDP into, it uses ports TCP and UDP 3389. And there's the VNC, if you use VNC for remote controlling a machine, that uses TCP port 5900. Then we come to network management and monitoring protocols used to monitor, troubleshoot, and configure networks. That's SNMP, which is Simple Network Management Protocol, ports UDP 161, 162. This is the protocol that switches or servers use to send out alerts, what is called SNMP traps. Okay, so if you have a server that's going down because, let's say, there has been issue, maybe it's overheating, for example, or a Cisco switch which has been compromised, can send out an SNMP alert to a syslog server, for example, and get information to say, hey, the server would say, hey, I'm overheating over here. I'm going to shut myself down. So, but you need to make sure you need to have a look at what's going on in here, right? So SNMP is an extremely useful protocol for managing your network, and you may want to set up SNMP traps in the network so that you get alerted if something like that happens, obviously, right? Then there's the ICMP protocol we use a lot for ping, right? For basic troubleshooting, trying to see if we can get to from one place to another. ICMP, Internet Control Messaging Protocol, used by ping and trace route. Now, ICMP does not belong to layer 4. It is a layer 3 protocol, right? When these protocols, they have layer 4 information, this one resides in the layer 3. Now, all these protocols I'm mentioning is application layer protocols, but they do have a component in the transport layer as well, which they use to connect to the application layer. In this particular case, there is none, right? So because it's a layer 3 protocol, so there's no port, but works on layer 3. Syslog server UDP 514. Now we talked about UDP and TCP when we talked about transport layer. So UDP is user datagram protocol. This is a connectionless protocol, meaning to say it doesn't create a connection before sending information. It just sends information. Usually UDP is mostly used for streaming information, whether it be a video streaming like Netflix, for example, right? Or audio streaming like Spotify, for example, right? So that's what uses UDP, or even like a conference call or YouTube, like a lecture we're just watching right now. That would be also UDP. But it's also useful for syslog servers, just logging events and stuff like that. Sometimes that's being used as well. NetFlow and IPFix, which is Cisco base flow monitoring protocol. Then there is the routing protocols. They enable routers to share network paths, right? So RIP, which is a routing information protocol, UDP 520. RIP is the protocol we had configured in some of the earlier lectures when we talked about Cisco Packet Tracer. So we have a Cisco Packet Tracer lab that we went over a few lectures ago, in which we enabled RIP, which is the routing information protocol, to enable routing on the router itself. So basically, two different networks could communicate with each other. Now, besides RIP, there's OSPF, which is the open shortest path first, using port 89. This is a very commonly and very popular protocol to use for routing. RIP is the easiest to configure, so that's what we configured. But OSPF is a better protocol to configure because it takes into consideration the latency in the network to figure out which is the fastest path to the destination. EIGRP, which is the enhanced interior gateway routing protocol, it's a Cisco based protocol. So this only works on Cisco devices, EIGRP. It's a great protocol, easy to configure, and it kind of uses the simplicity of RIP and the sophistication of the OSPF so that it's easier to configure and uses some of the features of OSPF. And that uses port 88. All right, now the BGP is the Border Gateway Protocol. This is a very common protocol used on the internet. On the internet, OSPF is not used as much. BGP is what people use on the internet. OSPF is something you use internally on the LAN. Then there is the spanning tree protocol, STP. This is a layer 2 protocol. There's no port associated because it's a layer 2, which is on the switches. So switches have the spanning tree protocol that is used to basically discover any loops in the network. If there's a loop in the network, the spanning tree protocol kicks in and shuts down the port, whereby it's kind of creating a loop. So it may shut down one of the ports. Basically, what happens is that if the same device is observable on two different ports, which should not be the case, but if it does, that means there's a loop in the network. It will shut down one of the ports that is creating this loop. Then there is the name resolution protocols. For example, if you want to translate human-friendly names like google.com, microsoft.com, right? So basically, we as human beings, we find these names easier to remember. So we go to the browser, we type in this information. For the computer, this information doesn't mean much, unfortunately, because the computer network works based on IP addressing, right? So basically, in this case, the DNS server is invoked, which will translate these names into IP addresses. So this is where the DNS comes into place, which is the DNS, which is the domain name system. This works on UDP or TCP ports 53. Then there is the MDNS, which is multicast DNS, which is used by Apple Bonjour, which is UDP 5353. Then there is the authentication and security protocols used for verifying identity, encryption traffic, or securing communications. So there's Kerberos, which is very secure. There's Radius, there's TACTAX, or TechX, I should say, and there's LDAP and secure LDAP used by Active Directory. Windows Active Directory uses this, right? Or you can enable Kerberos as well. Then there's IPsec for VPN access. And there is TLS/SSL. So as I mentioned, you want to use TLS 1.2 and 1.3 and avoid using TLS 1.0 and 1.1. And don't use SSL because TLS 1.2 and 1.3 are the most secure form. Right? So these are encryption protocols for HTTPS as well as FTPS. Then there is the file and print sharing protocols used to share resources across networks. SMB uses and CIFS uses TCP 445, as I mentioned. Try to make sure you absolutely need TCP 445 before you enable it. Mind you, if you want to use your tools to connect to C dollar share, then this will stop working if you disable this, right? On the other hand, if you leave this open, then this brings in the possibility of a worm in your systems, traversing or trying to attack every other system in the network. So you need to make a decision on that. Then there is the NFS, which is the network file system, TCP UDP 2049. Then there is the Internet Printing Protocol, TCP 631. So we've covered all the different categories of protocols and most of the protocols that are available in the application layer. Now we just want to give you, or I would like to give you a simple example of securing a web server. So a web server, basically what you need on a web server is Open 443, TCP 443, to allow secure web traffic, right? Optionally, you may want to allow SSH so that you can remotely administrate the machine if this is a Linux machine, SSH. And you may need to open 3389 TCP for RDP access if it's a Windows machine. However, very important, only allow access to ports 22 or 3389 from certain jump point machines. So what you need to do is you need to consider setting up jump point machines. So maybe a couple of machines that you log into, and only those couple of machines or 2-3 machines, whatever, depending on how big your environment is, are the only ones that can access these ports on a server. Right? So people, if they hack into the network, they cannot use this from any machine at all. They need to know the two machines that obviously you're going to try hide as much as possible and secure as much as possible. Only those machines from a very secure place should have access to your web servers. Otherwise, just close all other ports. In summary, we have covered all the 7 layers of the OSI model, right? And so this is basically a summary of what each layer does. So to summarize, basically the physical layer is used to transmit bits, okay, over the network. Okay, so this is basically ones and zeros in electrical form or optical form. Then there's a data link layer. That's where the MAC addresses come from. And this basically organizes bits into frames to provide for hop-to-hop delivery. So when we saw hop-to-hop, and we have discussed this in detail in previous lectures, this basically means from computer to a router or a router to a router. And so this is considered a hop, not to a switch. A switch is not considered a hop. So your machine, the first hop will be your router. So if you're at home, the first hop for you is going to be your internet router, right? Okay, that's going to be your first hop, even if you have a switch in the network. And then from router to router to router till you get to the endpoint. Then there is the network layer to move packets from source to destination. And this uses IP addressing scheme, whether you use IP version 4 or IP version 6. We'll talk in detail about IP version 4 and IP version 6 in later lectures. Then there is a transport layer. It provides reliable process to process message delivery and error recovery. So this is responsible for the ports, right? When we talk about ports, TCP ports, UDP ports, TCP and UDP are part of the transport layer. And the ports are extremely important because a connection is made from an application on your device to, let's say, for example, the web server, which is would be 443, right? Then there is a session layer, which is used to establish, manage, and terminate sessions. We talked about it in detail in one of the lectures. And presentation layer that is responsible for translating, encrypting, and compressing data. And finally, this lecture, we focus on the application layer. So we've covered all the all the OSI layers in all the previous lectures. And we'll go into a lot more detail as we move along the course. So this is a quick snapshot of the OSI model, the 7-layer model, as compared to the TCP/IP model, which is a very simplistic model, right? I find the OSI model is the most important model that you need to understand. So thank you for tuning in and thank you for watching. Next one, we will cover the knowledge check on the OSI model. So once again, thank you for watching. Have a great day. Please take care and hope to see you again. Bye-bye.